Okay, so in this tutorial we will find out how we can punch clouds. In case you're British, I suppose you probably really hate clouds, and I'm gonna show you how to punch them, how to cut them, how to send a laser to them to destroy them. And it's all gonna be done without any particles or like geometry nodes. It's just gonna be in shading. It's just gonna be a shader basically, and it will work for most versions of Blender. I'm gonna be using Blender 3.0, so keep that in mind. So here we are in 3.0. My layout looks a bit different. Don't worry about it. That is because I have set a custom theme for it. Basically, the first thing we're going to do is we're going to spawn in the volume in which we're going to be getting some clouds from. So I will squish this down a little bit because I know what I'm trying to get at. Something like that. I will Control A to apply the scale, and then I'll head over into the shading so we can start working with the clouds. Now right off the bat I want to set up something like EV. So I will need a light source, and I'll set the background to something like a blue color, and a light source that will be just like the sun. Give that a little bit of a rotation, probably make it a little yellowish, something like that. Give it some strength, and now we have something that we can work with. So basically, in your shading editor, add a new material, and we'll delete the principal BSDF and just plug in a volume scatter. Okay, so plug in the volume scatter, and now we have volume. Oh, it was compiling right there. Now we do have volume. You can see it. I hope you can sort of see it. It's not dense enough. If I bump up the density. Oh, and another thing, inside the render settings you also need to enable the volumetric shadows, because there we go. Now we can actually sort of see our volume a little bit better. So let's talk about how we're actually going to get the clouds. Basically, we have a noise texture. Okay, but we also have our coordinates, which are just texture coordinates. And before I get into anything, I want to say what the object coordinates, which we're going to use, actually outputs. So if this is our object origin, right, the object from the texture coordinate nodes actually gives us the position of every point in space. So over here, for example, this will be XYZ, something like 1 or 3 or like 5. That's a brilliant 3. Just a bunch of coordinates, and you can think of these coordinates as vectors that are going out from the center of our object coordinates in every direction, like sun rays. Okay, so that's what we're using to drive certain things. Like for example, I think the noise texture uses the object coordinates as its vector input over here. But basically what we're going to do is we're going to multiply, so take a math node, multiply our factor over here by these object coordinates, or more specifically, I will run the object coordinates through a vector math length. Okay, so when you do that and plug this into density, as soon as I find a way to clip that, oh, this needs to be multiply these nodes. I'll explain in a minute what's actually happening here. And I plug this through another math node that is set to less than, and I give this a value of around 0.5 or something. We will start to see that we're getting something like clouds as soon as I bump up the density over here with a multiplier. And my clouds are really low resolution. To fix that, inside these settings I will just change this to something like 2 pixels. That will make them much crispier. And at this point I would also reduce this amount. The start and the end is basically how the samples are distributed to Neve, and I want to reduce this as much as I can before I start to cut away from my cloud. Okay, something like that. And yeah, we can now see the clouds. And what we want for this noise texture is maximum detail and roughness around half. There we go, that looks like clouds. It will look even better in cycles, but this is for performance sakes. So what I actually do here, I took the length, so every vector, like I talked over here, you can think of these positions as vector, and every vector has a magnitude or a length, and that is just the length of the vector itself. So if I just take this, if I take this vector that's coming out of here and plug it through a length node, I just get a single value, which is the length. And you can think of this as just a bunch of rays or just concentric circles around our object origin. In 3D space, also they would be spheres in 3D space, and all of these have a value associated with them that starts from 0, 1, 2, 3, because that is simply the length of a vector at that location, 3 for example. And you know, it just goes off towards infinity. So that's how I think about these things, at least. I hope that helps you. And that is basically our noise done for our cloud. But how do we get multiple clouds? Well, instead of having one object coordinate, we will need multiple object coordinates. To do that, we will use a Voronoi texture. And if I just plug this, well, I guess I can show you the best way with a plane. So spawn in a plane. I will really quickly give it a throwaway material that I will just call example, I guess. And if I plug into this plane a Voronoi texture, if I just plug the distance to the surface, you'll see that this Voronoi texture gives us the following things. And if we set this to distance to edge, then we will get the distance from the center point of these things to the edge. Okay, so we can think of each of these as just separate coordinate systems, right? It's as if I have an object. However, I cannot pull out my grease pencil because I don't have a hotkey for it here. That's fine. So we can think of these as separate object coordinates, like I said over here, right? The object coordinate that just goes in every direction, but it doesn't go forever towards infinity, but rather is constrained to this area over here. And basically it's like I have a bunch of objects inside my object right now. Okay, so what happens when I actually plug this, if I delete that, we actually plug this Voronoi texture based off of distance to edge. I would also need to flip it. In fact, maybe I deleted that too quickly, because you can see that this is at a value of maximum at the start and minimum at the end, but we want to flip that. And to flip that, the easiest way is just to pass this through a math node set to subtract from 1. So we're passing this value that is actually between 0 and 1 to be 1, 0. Okay, so plug this here, set this to 1, set this to subtract, and now we have flipped this. And instead of multiplying by the coordinates of our object, we will now multiply by the coordinates of this Voronoi texture. So immediately the first thing we're going to want to do is, I guess, change the scale of it, because the smaller the scale, just give me a second here to adjust these things, because the scale is important. You would also need to change this less than factor, make it even smaller. There we go. That's about it. I might actually increase the samples of my volumetrics from 64 to 128. And I also doubled the shadow samples. Okay, so now we see that we have clouds, and the scale here determines the size of these clouds, basically, or their number. So a small amount doesn't equal that many clouds, and so on and so forth. And if you change this to 40, you can actually change the W to get a different configuration of clouds as soon as it compiles. At least I hope it does compile. Why does it not compile? Oh, yeah, I was just in a location with no clouds. So you can see I'm changing it. They're too big now, so I can actually increase the number, which will give me more clouds in my space here. And I'm shifting the W, I'm getting a different configuration of clouds. If I hold shift and click it, it will move the slider more smoothly. But basically, yeah, this is how you would get your cloud. Now the problem is that at the edges, they're instantly getting cut off. We can see that, right? There's a cutoff here because our volume ends, and we basically want to soften that up. Now there's two ways. I'll show you this way first. It is using the object, rather the texture coordinates. There we go. And then what we're going to use is these generated coordinates instead of the object coordinates. Now what are the generated coordinates? They basically give you a value between 0 and 1. Okay, so if I have my cube, the generated coordinates will be based off of my geometry. That's how you can think about it. So a value of 0 here and 1 here, and that is for all the axes. X is 0, Y is 0, Z is 0, all the way to 1 here. Which means that if we want to shift this center now, which is at the corner, I guess I can show you that if I just use a multiple. If I multiply this by these object coordinates, after I get their length, of course. So vector math, plug in the generated coordinates into length, and then plug that into here. And I would also need to add a less than for this, I believe, so that we can get that cut off. As soon as it's done compiling, you can see how we're basically moving away from our object, but we're moving away from by a corner. You can see they're starting at the corner, and we want to move that to the center. That is very simple. just another vector math over here set to subtract, and we're going to subtract 0.5, which will center this. And now when I change this, you can see that there's a 1 second. It is oops, I didn't connect it. There we go. As soon as it's done compiling, you can see that now we have like a sphere going from the start towards the end, but we also want this sphere to have the noise imprinted onto it. What that means is I want to also multiply it by the noise, which we got over here from our noise texture. So multiply that by the length. And if I now change this factor as soon as it's done compiling, we can see that we can now get this soft cutoff at the ends. So this is one way. Essentially what we have done is we have created an, I think it's called an ellipsoid, this flattened sphere which is inside our cube. That's one way of doing it. I'll now show you the other way of doing it, which is basically cutting it based on direction. So let me show you that. I might just keep this just so I know that it's responsible for one type of masking, and I'll just cut these off. Again, this will be using the generated coordinates. However, the first thing I'm going to do is, again, I guess I will shift them again. I will not get the length, but instead I'm going to vector map them and multiply them by our noise. Okay, so take the noise again, multiply it here, and then I'm going to do a separate XYZ so I can get the different X, Y, and Z components and run through a math node set to compare. Now I can plug the X and I can set value to 0, and then after I multiply that over here, I should be able to, if I go onto my X-axis, shift them using this epsilon value. You can see how we're now cutting based on the cube itself. So this is the second way of doing it. The reason this is working is basically we're saying, alright, at the value of 0, everything in a range of epsilon. So if I set that to 0.25, that will be 0.25 in every direction, which will be the entirety of our volume. We'll return a value of 1. Okay, I hope that makes sense. So basically you want this slightly below that, so we're not cutting off the clouds. And you want to have this for the Y and the Z axis as well. So Shift D to duplicate these. Okay, plug the Y here. And then to just combine these, you have to multiply them together. So I'll just do this, or I'll take them like this, like so. Multiply again. And finally, then I will add them over here. And now I should be able to do the exact same thing for every direction. This is for the Y. If I look at the Y, see this is my Y-axis. I can cut them on the Y. I'll leave it 0.2, and I can also do it based on the height, like that. So that is the other way to mask it. A bit more convoluted, but I don't think it's much less performant. So yeah, I guess we can now continue towards the actual punching of the cloud, because so far we've only talked about the clouds, how we're going to generate them. Now to punch the clouds, I'm first going to have an object which will dictate where the force is, where the punching starts from. So let me spawn in an empty plane axis. I'll scale them down a little bit, like so, and I'll rename them to pusher, for example. And I'll keep it in the middle for now, and then I'll have to bring in the coordinate of pusher in here using this texture coordinate. If I just duplicate it, I can pick a custom object pusher, and this will be the exact same thing as having the regular coordinates. So for example, if I have my object coordinates and I move my pusher object, it will just be slightly offset from it. And again, all of them will have a bunch of values coming out at every direction. Okay, so it's basically its own coordinate system that I'm now going to get out of this object, and that coordinate system is based on my pusher. Alright, so what we're going to do next is we're just going to first off, we have to make sure that our object is using, or rather our noise and our Voronoi are using the same vector space. So in other words, I'll use the pusher and plug that into the vector of those two. This will probably mess things up because I think I scaled the pusher. Now I'm gonna have to change the scales, it's too fine right now, so I'll reduce that, and I'll also have to do the same for the noise until we're back to something that looks more like clouds. I guess this is fine. Well, this shouldn't be negative, that doesn't make a lot of sense. Yeah, this is fine. This is fine. And then after that, we need to talk about how we're actually going to do this. Basically, I'm going to use a vector math again to get the pusher's coordinates as length once again. And then I'm going to run that through a map range. Map range, not mapping, map range. Okay, and then I'm going to plug the map range, and I'm also going to scale these coordinates, so another thing here, which is just set to scale. Scale. Plug it in again because that destroyed those connections. So in the middle we have this scale value, and what we're actually going to be scaling by is this value over here. So plug that in, and once I set this value over here to 1, I think. Actually, I think it's gonna work now if I just change. Yeah, there we go. See how now we're pushing the clouds away. And yeah, so let me explain what I actually did here, because I know I just said yeah a bunch of times. Basically, I took those object coordinates we talked about, and we know that they are just points in space. And after I run them through a length, we can think of them as just spheres around our object coordinates that are essentially just the distance from the object coordinates. So over here in the middle, it would be like 0.5 and onwards towards infinity. And then what I said, okay, take the distance and map it so that from the range of 0 to 1, so 0 to 1 would be this range. Let me just remove some stuff so it's better to see. So from a range of 0 to 1, which is this range, okay, I want you to remap them to be something like, well, okay, let's change this a little bit. From a range of 10, that's too much, 5. I guess I would need to draw that out. So from a range of 0 to 10, or to 5, I want you to remap these coordinates to be 0 to 1, okay? So basically what I did is I took this space of 0 to 1 and I stretched it out to be from 0 to 5. Okay, essentially pushing everything outwards. And you can see that all I'm doing is I'm stretching. You can even see the cutoff over here where it starts to actually stretch it. This would be the cutoff of this sphere over here. Right, I really hope this makes sense. And you can see I'm moving it and it's increasing. And the value from minimum actually affects where the stretching starts. I hope that makes sense. What I mean by that is if I have this value 1 here and a value of 3 over here, then it is taking the space between this value of 1 and the value of 3, and it is remapping it. So it's taking so it's taking the space from 0 to 1, again this space, and just taking this vector that is from 0 to 1 and remapping it over here. In other words, if I have this to 3 and this also to 3, or slightly below 3, maybe it will be better if I set this to 2 and slightly below 2. You can see if these are very close together, I have basically stretched this entire space into this very thin sphere. Okay? I really hope all of this makes sense. So now all you would need to do to animate this, for example, is go into your pusher right here. At least I hope it have it selected. Go into the object properties and scroll down. And the custom properties, you're going to add a custom property, which is just a value, and set its minimum to 0 and its maximum to like 1000. And we will call this custom property push start. Okay. And then do another one called push end. Okay, 0 to 1000. Okay, then I can select my volume again. If I click this little pin button, I think it will stay. Yeah, okay, so now I can select the pusher and I can still see my shader. I can select push end, right click, push end, copy as new driver and plug it into the maximum value, paste driver, and do the same for push start. Copy as new driver and paste it right here. And basically I can now control this from these values of the pusher. This is where the pushing ends, and this is just where it starts. So how much it's compressing space and where it starts to compress it from. You can think of it that way. And if it's 0 to 1, there's no difference. It's like there's nothing there. Alright, so what do we actually talk about next? How do we... So this pushes in all directions, right? But check out what happens if I just take this texture coordinate and run it through a vector mat. Oh, it's set to add. I'm sorry, this needs to be set to multiply. Multiply, and then if you multiply z by 0, you can see that now what we're getting is sort of like a laser, the laser effect. It's not pushing in a sphere, it's now pushing in a cylinder. Okay? So the reason is because I flattened the z-axis. That's all I did. I flattened the z-axis and that turned the sphere into a cylinder. So this is how I'm pushing in all directions. I mean in like a cylinder. And the next logical thing is to flatten one more axis, in which case you're now making a cut through the clouds. So push start should be 0, and now you can see how I'm just cutting the clouds in like a line. So these are all the effects I used in the video I showed at the start. And next we need to talk about the drawbacks of all of these techniques, because so far so good, right? But there are some drawbacks that need to be mentioned, and I'll also give you a hacky solution to them. Basically, now our object is based off of the coordinates of our pusher, which means if I take the pusher, you can see all of my noise and Voronoi moves with it. Okay? Which means if I want to actually change the direction of this effect, I need to move the entirety of the scene. This might be an issue. So this is one of the issues. The other issue is I cannot have multiple pushers right now. And also I cannot really push a single cloud. I can really only push a collection of clouds. So let's see why this is an issue. All I'm going to do is I'm going to take this thing and I'm going to use its coordinates, which is just my object. These are my object coordinates, and I'm going to scale them. And let me undo this multiple, so we're doing it in a sphere. And as I'm changing the start and end, you can see, okay, so it works. And now I can move the pusher independently of the world space. It works fine. However, if I take the texture coordinate, or rather, if I move the vector coordinates of the objects, which I can do if I just press N, go into Tool and do Origin, in which case I'm not moving the geometry, I'm only moving the origin. And you can see if I look from a top-down view, as I move the origin away, you get this very weird effect where the clouds are sort of stacking on top of each other the further away the pusher is from the origin. And the reason why that is, I need to explain this. So if this is our object origin and this is the pusher over here, a bit smaller, what we're doing is we're scaling the vectors of the object origin. Again, you can think of them as vectors starting from the object origin by an amount that is based off of the pusher. Okay? But then, the further we go out, the bigger this vector gets. And more importantly, is again, you can think of this scaling around the pusher as going from 1 at the end to 0 at the start. Okay, but we need to remember that this is the coordinates. These are actually coordinates. So when I scale this vector to 0, it basically thinks we are at the center of the world. Okay, because I just scaled 1 to 0, and it took all of this distance and it basically flipped it and compressed it into this distance. And that is why the more I move away from the object origin, the weirder things get. You can see that's exactly what's happening. It's compressing the entirety of the space from the object origin. Okay, so how can we fix this? Fix this in quotations, because this isn't really a great fix, but basically instead of scaling where our pusher is, instead of scaling everything from 1 to 0, we are just going to take these vectors that are coming out of the object origin, for example this vector here, and remember this has two positions associated with it. One is the distance from the object origin, the other is the distance from the pusher. And what I can do is I can move this away from the object origin using this pusher vector. essentially all my rays will then be going like this, although they're not really rays, I'm visualizing here. In reality, what I would be doing is I would be taking every point around the pusher and moving it away. Okay, moving it away from the pusher, and again every point is just a vector from the object origin. Okay, so let's try and see what happens when we do that. So instead of doing scale, we want to do subtract. We want to do subtract, and what we want to subtract by is the vectors, this thing, the object of our pusher. But what we want is to normalize the vector of our pusher, because we only want to use this as a direction. And what does it mean to normalize? Basically, like I said, from the object origin going out, they're just rays. The further you go out, the bigger they get. But when you normalize it, it basically makes all of their lengths equal to 1. So if this has a length of 1 and this has a length of 10, once I normalize it, norm, this will still have a length of 1, although I will definitely not draw it the same way. And this will have a length of 1 as well. There we go. And that is because we only want to use this as a direction, because we're going to scale it right over here. If I plug in a node set to scale, we're going to scale it with the way we have just remapped it using the distance, like so. And only then will we actually subtract. After watching the tutorial, I realized I actually forgot to add the normalize here. Basically copy this right between the scale and the texture coordinates and set this to normalize. It's important. And what we want is to scale it such that these vectors, whenever they're at the edge of this, at the 2 mark, for example, a radius of 2, we want them to be pushing the rays that are coming out of our object origin with a value of 0, so basically a length of 0. So to do that, we're going to set maximum to 0 and minimum to 1. Okay, which means that at the start, all the vectors are pushing with a value of 1. At the end, as they get closer towards the end, they get smaller and they start pushing the rays away less and less. And now you can see that I can now move this. Actually, let me pick up the pusher. I can now, come on, I want the pusher go. The pusher won't move because I'm moving the origin. Now I can move the pusher freely, right? Perfect, like no issues. However, if I want to increase the push range, I can do that easily. Again, the same way. But I will be changing the push force by changing the strength at the center, which is the strength of these vectors. So see what happens when I actually boost that up. Oh, we start to get clouds in the middle. Why are we getting clouds in the middle? The reason for that is essentially as I'm increasing this value, the push vector gets at the center gets bigger and bigger, and eventually it gets so big that it reaches out, and if there's a cloud over here, it will display that cloud. Okay, so that is an issue that I don't really have a perfect fix for, but what we can do is we can just use this object, the pusher. Let me just show you. If I take the length, plug it in, and I will use a distance from the pusher as a mask to remove these residual clouds. So I would need to set this to, I think, greater than, and then after this less than node, which is what we use to make our clouds at the start, we want to add another multiply node. Okay, and then we want to plug in the result of this greater than into our multiply node, and essentially, or this might need to be set to less than. It's one of the two. Yep, less than. We can see that as I change this value, we get this mask going. Although things suddenly look very horrible, and that is because I plugged this into the wrong socket. Okay, I plugged it into a threshold, not into the multiply. My bad. This needs to go into the multiply that is after the less than. Okay, so now you can see I can cut these residual clouds out manually. And you would have to do this manually, so if it's animated, it becomes a bit of a chore. That's why this is sort of a hacky fix. But the way to do this then would be to add a new vector. We would call this one push strength. Okay, and just copy as new driver. And this will be controlling the 2 minimum value. Paste. And now from here we can, I hope, yes, we can control the push strength. However, it is set to a maximum of 1. I want it to have a very big maximum. And we would need one more thing called trim, which will trim the residual clouds. Again, set that to a very high maximum. Copy as driver right here and paste it over here. Paste driver. So now we can trim and we can push to our heart's content, and we can also take our pusher and move it anywhere around without affecting our clouds. And technically, if you just duplicate this pusher and duplicate the entire node network, you should be able to add another pusher. In fact, I've never tried to do this, but let me try now. Let me just clear these. So I will duplicate this pusher, rename it second pusher, and in here I guess I'll just duplicate all of this. However, with the second pusher it would need its own controls. So you can see how it removed my drivers. I probably won't add this right now. Rename the texture coordinate to use the second pusher, and then what we need to do is add another subtract value after this texture coordinate, after the first pusher has had its effects. So another value right here. If I plug this in, I haven't done this before, so I'm not sure if this will work. So basically the remapping I think is not quite right, or rather I've added two subtract nodes, my bad. I just need the scale to plug into this subtract up here, and please, yeah, now we can have two pushers. Of course you would need to link up another less than node, which will go in another multiply node between these and these. This is just for the density. If I remove it, you will see my clouds become way less dense, basically invisible. So this is just density. Sometimes I like to rename my nodes so I don't forget what it controls. So this would be pusher 1 cutoff, and over here you can plug in pusher 2 cutoff. But again, you'd need to give it its own drivers and whatnot. So that is basically it. Let me think what else we need to do. This is the setup you would need to use if you have a single cloud. So I guess I need to show that. Let me show that by making a single cloud. As soon as I figure out why this is all grayed out, because that's a very good question. This is it. Oh, because I pinned it. My bad. So I need to unpin it, and then I can click this new material to actually copy this, and I'll call this single cloud. Like I said, the single cloud doesn't need the Voronoi, because all it uses, and I guess it won't need the subtract, all it uses is these texture coordinates. I think this should work, although I will need to plug this in through a length to get the actual length, and then plug this in here, and I should get a single cloud. I do, if you can even see it, because I need to really bump up the threshold. I need to really bump up the density. Okay, now we can see it, and again we're pushing it. So this works when you have this setup, but if I have the setup where everything is based off of just the object coordinates, so if I remove, I guess, half of these nodes, honestly, plug this into a length, plug this into the multiple for the noise, and also to drive the noise. The reason is that now this will always have the object origin. The reason it works now is because of this less than, but if I remove the less than by just deleting it, the issue is that at the center of this there will always be a cloud, because we're basing the location of the cloud based on the origin, and the origin is just the pusher. And if there's always a cloud there, it will never push anything away. So if you want just a single cloud, you definitely want to go with the hacky fix that I have given you. But yeah, basically, now I should be able to, if I go back to the other one, the other setup, where it still used the object coordinate to drive the vectors. Now we have a single cloud, and I can push this away, all I like, from within the properties of the pusher. So I can go push end, huge, Of course I need to adjust the trim, so we're not trimming any more than we need to. And yeah, you can basically start pushing. However, you might want to increase the space you have for the volume, just to see everything. And what else can I tell you? I can give you some general tips on render index because it is super slow in cycles. I'm sorry, but cycles, volumes, yeah. What you would want to do in cycles is, if you want to get very high quality, just bump up. Oh my god, I can hear my CPU. Decrease the step render sizes, and that will just give you much finer clouds, much detailed clouds. Yeah, so that's one thing I can suggest if you want fancy renders. I did the renders at the start with Eevee just because I have a shitty GPU. But yeah, so how would you actually animate this? Well, we have our properties right here, custom properties. All we need to do is push out a timeline. Wow, this is waggy. Change the timeline over here to something like this. And just start keying things. If I press I while over a value, it will add a key for it. Then I can go forward in time and I can increase the push end to push the clouds even more, key that, and now you can see it's sort of animated in the middle. And I'd say it's fairly performant, definitely more performant if you're using particles. There's no way you can see particles in real time like this. And yeah, one more thing I guess you need to play around if we're going to be using Eevee, just with the start and end, so we can get more samples where we need them. Also, you can add a general volume to this. If after everything you just add a little math node that says, okay, add to everything like 1. This is how you can just add volume on top of the clouds. So you can get those god rays, essentially, which look fairly cool. But yeah, thanks for watching. If you have any questions, leave them behind, because I guess this was one of those more mathy videos where we had to talk about vectors and whatnot. Subscribe for more epic effects. I guess I'm just making Blender VFX at this point. And bye.